Hi guys, welcome to Introduction to Rust. My name is Tensor. Today we're going to be using the Rust Iron framework to build a web API. Our web API is going to be sort of Twitter-like or blog-like. It's going to be fairly basic. The point of this tutorial is to sort of give you the gist of how to build web apps inside of Rust. So I've created a project here. This is just simply called Web API. So these are the dependencies what we're going to use. This is the Iron framework dependency. This is the Iron router dependency. So this gives us the ability to use routes and stuff inside of Iron. This is a logger library which allows us to do a bunch of logging. We also have our environmental logger. Then we have our Rust C serialize, which allows us to serialize data structures into different formats. In this case, we're going to be using it to serialize our data into JSON formats. This chrono library, we're going to be using it to embed timestamps into our JSON. And then this UUID library is used to help us build unique user IDs inside of Rust. Unique user IDs have various formats. We're going to be focusing on version 4, and because we also want to have it serialized into JSON, we're also specifying that we want that as well. When building a web app, the first thing I like to do personally is model the data. In this web app, we're going to have a title, a body, an author name, and we'll have a timestamp, and then we'll have a UUID. And this will be the basic structure for each of our posts. I'm going to create a new file called model.rs so that we can hold all of our models in here. I'm also going to jump back into the main file and type in models. Doing this will not only give us linting inside of this model.rs file, but it will also make the model.rs file into a submodule of our main binary. While I'm inside of the main file, I also want to bring in all of our external crates so that they will also be exposed inside of models. So I'm bringing in external crate chrono, the environmental logger, the Iron framework, the logger, the router, Rust C serialize, and UUID. Inside of models, I want to bring in the chrono datetime type. I also want to bring in the chrono offset UTC type, and I want to bring in the UUID type. Our first data structure will be called post. The first field inside of it will be a title of type string. Then we'll have a body of type string, and finally we'll have an author of type string, a datetime of type datetime, and a UUID of type UUID. We're getting an error for datetime, so UTC gets wrapped in the datetime type, and this specifies what type of time we want. We're going to create a few methods for post. We want to create one that will allow us to create a new post. This new function will take in a title, which will be a reference to a slice of string, then a body, which will also be a reference to a slice of string, and then the author will also be a slice of string. Then we will have the datetime, which will be type datetime UTC, and then we'll have the UUID, and this function will then output a post. This method is fairly basic. We're just going to instantiate a post, and inside of the title we're just going to convert our slice of string to string. We'll do the same for body and author, and then for datetime we're just going to assign the argument that gets passed into here to datetime, and the same goes for UUID. Next we want to create a simple little method called UUID, which takes in a reference to our post through reference to self, and it will return a reference to a UUID. So this is simply for us to be able to quickly get access to the UUID field in our posts. And so accordingly, the method will return a reference to self.uuid. We also want to make sure to go to the top of our struct here and derive a few things. We want to be able to clone our posts. We want to be able to debug them. And most importantly, we want them to be Rust C encodable and Rust C decodable. Deriving Rust C encodable and Rust C decodable allows us to have the Rust C serialize library automatically encode and decode objects to and from JSON. Most of the code inside of this models file is fairly self-explanatory. For this tutorial, rather than actually using a real database like Postgres or SQLite, we're going to create a few functions to allow us to store our posts in memory. We want to create a database.rs file, and in main we also want to make it into a submodule of our main binary. Inside of our database, we just want to expose models post. We are going to define a struct called database. It will have a field called posts, which will be a vector of post type. Now we can just use use this vector to simply store all of our posts in memory. And this is the best way to do things because with vectors, we're very easily able to add and remove items. We also want to annotate this with clone and debug. Clone is mainly because we are going to be making this multi-threaded. We're going to make 3 fairly simple methods for this database. The first one will just simply be called new, and it will take in nothing and just output our database for us. All we're going to do is instantiate a database and initialize the posts field by adding an empty vector to it. Then we want to create a method called add post. This will take in a reference to our mutable self, which is our database, and then take in the post that we want to add. And then we'll simply call self.post.push to push our post inside of our vector. We'll have a method called posts, which takes in a reference to self and outputs a reference to a vector of post. And we're just going to use this method to make it easier for us to expose the posts field from our database. So we implement it simply by returning a reference to self.posts. So now that we've defined our data and a simple in-memory data store, we will be looking at the meat of our application, so the actual handling of our web requests. To do this, we want to create a new file called handlers.rs, and again we want to go back into main and make it into a submodule of our main binary. We're going to have quite a few imports into this particular module. We want to use our arc and mutex so that we can have shared data. We need to bring in our read trait so that we'll be able to read from our database. We also want to bring in quite a few things from the iron framework. We're bringing in this status function here. We're bringing in a type called after middleware, a type called handler, a type called iron result, a type called request, and a type called response. Now we'll go over exactly what these types do as we get to them. We also want to bring in from iron headers the content type. This is fairly self-explanatory. It will allow us to set the types for our headers. We also want to bring in rustc serialize JSON. This will allow us to serialize our data into JSON format. Finally, we want to bring in our database struct. Then we want to bring in from the UUID library the UUID type. Then from the iron router library, we want to bring in the router type. And we also want to bring in our post struct from our models, as well as the standard library error type. So we're going to be using 3 macros for our code in here. I think it's kind of underused to use macros and other metaprogramming structures like this. And when you have a language like Rust, it's definitely worthwhile to explore using them inside of even the most simplest of programs. We're going to write a macro that will allow us to match a result to get the inner value. And if we get an error back, then we want to return an internal server error. So this macro is sort of similar to the try macro that already exists in the Rust standard library. If we take a look at the actual breakdown of this macro, it's fairly simple. It's made up of 2 cases. We have the top case in which we just pass in one expression and we then match on that expression, and if we get back OK, then we just take the X out of OK. Otherwise, if we get back error, then we return an OK with a response, status internal server error, and then we want to put in the error description. Our second case is a little bit more general, so we're taking in the first expression and then an error expression. Then we're matching on E again, and for the OK, we do exactly the same thing as we did up here. And then for the error, instead of returning a status internal server error, we're going to return a specific error that we pass into the macro. So our second macro allows us to write lock mutex rather than writing mutex.lock.unwrap. This is basically for the sake of saving some space inside of our code. So we're also calling unwrap on all locked mutexes in this code for simplicity's sake. Now granted, this is something that you'd probably do on all mutexes, so it's something that we don't really want to just keep repeating everywhere. We can just write lock on the mutex rather than just writing out mutex.lock.unwrap. Now our final macro will look a little bit more complicated, but it really isn't. So our third macro allows us to easily get a parameter from an HTTP GET request. If the parameter is not present, then we return a bad request. If something goes wrong, then we return a status internal server error. First, we use this first match expression to make sure that we can get to our router. If this isn't possible, then obviously something went terribly wrong, so we return this internal server error. Otherwise, we then match on router.find, which allows us to find the parameter that we're looking for. If we find the parameter, then we unwrap it from sum and we send it back. Otherwise, we return the bad request error. Again, this macro is just simply to make our lives a little bit easier. Now that we've written all of the macros here, we want to create a struct for our handlers. This will take in a handler called postFeed, which will be of type post feed handler. Then we'll have a type called post post, which will be post post handler. And then we'll have another field called post, which will be of type post handler. So these will be specific handler types that we can then pass into our router. Now we do want to make a simple method for our handlers struct. So with this new function, we create a database variable by taking a mutex and putting our database inside of it, and then putting that inside of an arc. And then we give it to every single one of our handlers by cloning it. So we want our data to be accessible to all of our handlers. We want changes from one handler to be visible in the other handlers immediately. And we also need this to be thread safe. And that's why we're wrapping our database inside of an arc and a mutex. So now let's create our post feed handler. Our post feed handler will be a struct, and it will have one single field, which will be the database field, inside of which it will have a database wrapped in a mutex, which is wrapped in an arc. And then we will create a method for our post feed handler, and this will take in our database and it will output a post feed handler. So this is a fairly simple method. All we have to do is instantiate our post feed handler. Then we want to implement the handler trait for our post feed handler. So this handler trait comes from our iron framework, and inside of it, it has a handle function. This handle function takes a request and returns an iron result with a response inside of it. In this case, we're going to be passing a reference to our post feed handler inside of it as well. And we also don't care about the request, so we're going to make that anonymous. We define a variable called payload. Then we use our macro try handler on JSON encode. And then inside of this, we use our lock macro to unlock our mutex on our database here. And then we call the post method on top of that so that we can encode all of our posts into JSON and then put them inside of this payload as a string. Then we pass back an OK with response with inside of it. And inside of that is a tuple with status OK and our payload. The iron result here is basically iron's version of the Rust result. It's basically the same thing that's just been implemented for HTTP requests and responses. In this case, we're passing back a response wrapped in a result that specifically has a few more things added to it by iron. So the handler trait itself signifies to iron that this is going to be a handler, and it also gives it the send and sync as well as the static traits. So our post feed handler just returns all of the posts in a GET request. Now let's build our post post handler, which allows a user to add a post to our database. As with our post feed handler, we create a struct for post post handler, and inside of which we have one field called database, which is a database inside of a mutex and an arc. Then we create a method called new, which takes in our database type and then outputs a post post handler. And then we just instantiate post post handler and we put the database inside of our database field. Then we want to implement our handler trait for our post post handler. Our handle function inside of this implementation is going to take a reference to our post post handler as well as our request. So we're actually going to use our request in this one, and it's also going to return an iron result with response inside of it. The handle function for our post post handler is slightly more complicated. First, we obtain our payload from the request's body. So we create a mutable string here, and then we read the body into our string using this read to string method. And of course, we wrap this in our try handler macro. This is the data that we're sending to our HTTP post request. So then we try to decode our JSON here, and if it is malformed, then we return this status bad request. So if you remember our try handler, the second expression up here takes in our expression and our error, and this is what we're invoking here. So if this succeeds, then it will not set status to bad request. Finally, we grab the lock of our database, and then we add our post to our database, and then we return a response with status created and our payload. This will return a 201 created along with the original payload. So our post handler is our last handler. This is for when we want to look at individual posts. For this, we need to have a URL parameter. The struct is going to look like the other structs that we have, just a database with a arc mutex database inside of it. We will also have a new function that is exactly the same as the other two, but we want to have another method as well for this particular handler. So this second method for our post handler will be called findPost. It will take in a reference to the self as well as a reference to our UUID, and it will return an option of post. And this method will allow us to look through our database for a post with a matching ID, and if we find it, then we'll return it. So basically we grab our mutex index and unlock it by using our lock macro. Then we create an iterator by calling lock posts iter. So an iterator with all of our posts in it. And then we iterate through that iterator, and we use the find method to find a post where the ID that we're passing in here is equal to p.uuid, and then we map that to p.clone. So if we do find a post that succeeds in making this statement true, then we take that post and we clone it. And that's what we return here in our option. So we also want to implement handler for our post handler. And this means, of course, creating a handle function. So the handler attempts to find the ID parameter using our macro. If it finds it, it tries to parse it to the UUID. If it's malformed, then we return a bad request. So that's what's happening here. If we do find a post though, we destruct it by using this flet binding and pattern matching self.findPost with some post. Then we encode it in our JSON, and we use our try macro again, and we return it with 200 OK, so status OK. If we do not find it, then we return a 404 not found. So we're almost finished with our handlers. There's one more thing we want to do. The Iron framework makes use of middleware. There are 3 different types. There is before middleware, around middleware, and after middleware. Before middleware can modify requests before they get handled. Around middleware modifies requests before and after middleware modifies them after they are handled but before the response is sent. In this case, we want to use after middleware to make sure that our responses have the correct content type, which will be application JSON. We just want to create a unit struct called JSON after middleware. Then we want to implement the after middleware trait for JSON after middleware. To implement this trait, we just create a function called after. This takes in our mutable self, then it takes in our mutable request, and then a mutable response, and then it will return an iron result with a response inside of it. We just look at our response here, and then we look at the headers in the response, and we set them to be content type JSON, and then we just return the response inside of OK. Now we have defined all the code that is needed for a data store, and our handlers. It's time to sort of put everything together so that we can have our running REST API. Now we just need to add our use statements. For our submodules, we want to use our module, and then we want to define it as a glob. Then we want to use our database struct. And then for our handlers, we want to use, again, a glob pattern. So everything that we've defined as public thus far instead of the handlers module. Then we want to use iron, prelude, chain, iron, router, logger, and UUID. In our main function, we start by initializing our logger and creating a pair of before middleware and after middleware. We initialize our logger by simply doing this. And then we want to take a tuple with logger before and logger after and assign it to logger new with none inside of it. Now, because our database is in memory, we need to create the database entries inside of our main function. We create a mutable database by calling database new, and then we create our first post here by calling post new, and which we put in our title, our body, our author, and then we call chrono offset UTC now to get the time right now in UTC time, and then we call UUID new version 4 to get a new version 4 UUID, and this is a method, by the way. Then we'll create a post number 2 called P2, and again we'll put in our title, our body, our author, and our timestamp and our UUID. And before we actually create our second post here, we want to call db add post on our first post so that we get it into the database first, and then we'll call db add post on our second post to put it in second. So now we want to instantiate our handlers and our JSON content middleware. We do this fairly simply by calling handlers new with our database and then simply adding JSON after middleware and binding it to a variable. Then we want to create a new router. So this will be mutable because we're going to add routes to it. And then we simply just call router new to create our new router. And we can add our routes like this. So you can see here, I just call router.get for our get method. Then I put in the index that I want. Then I put in the route that I want. In this case, I want post feed to be bound to post underscored feed. And then I just put in something to specify what the handler actually is after I put the actual handler in right here. For the other two handlers, I want to get a post request for our post so that a user can actually post that post request to our post feed and to our database. So we just say we want it on route post, and then we put in the handler name, and then we just name it post. And then for our last router, we want to have a dynamic route. So we use post and then this colon ID. And so the ID is actually corresponding with our UUID. Then we just pick out our handlers.post, and then we just call this one post. We also need to define a chain for our middleware. The way that I like to think about this chain is to think about it sort of like we're creating a workflow or a pipe. And as we send our requests through our pipe, it goes through each thing one at a time. So first it goes through our logger before, then it goes through our JSON content middleware, and then finally it goes through our logger after. And if we were to add more links to this chain, then it would slowly be mutated by each link as it goes through. All right, so now finally we can serve our HTTP server, and I'm going to bind this to localhost 8000. So we just call iron new, and we call this on chain, and then we just say HTTP, and then we put in the localhost 8000, and then we want to unwrap this. Now I found a small error with one of my macros here. You can see that I accidentally mistyped the parentheses inside of these angle brackets. If I remove them and put them on the outside, things should work properly now. I also forgot to put in the S for our models here, and as a result we had some errors going on in here. So here I've opened up Postman. This will allow me to send various requests to our server. You can see here that I've sent in a localhost 8000 post feed get request, and here we get our two posts in JSON format. They have a title, a body, an author, the date time, an offset, as well as our UUID for each of them. So you can see here 2 UUIDs, and I can query, say, the second post here with the UUID for the post by typing in post / and then the UUID afterwards. Now I just get the second post by calling post / UUID. Alright, so we can also send a post request through Postman. We do this by clicking params here and then opening up the body, putting in the raw JSON, and I've put in our title, our body, and our author, and then I also put in the date, time, and the UUID. Of course, if you were actually building a front end, you would create something that would handle both the UUID and the date time so that you wouldn't have to manually put them in every time. But if I leave them out, then things kind of get screwy. Alright guys, well I hope you enjoyed this tutorial on Iron and Rust and building Rust APIs. If you enjoyed it, feel free to subscribe and like. If you have any questions or comments, feel free to leave them in the comment box below. And if you disliked it, then by all means, downvote it as much as you'd like. Have a good night, guys.